Ever seen symbols like this?
Like this?
Like this? Or this, on a blueprint and had no idea what they meant? Let's talk GD&T, the language of precision. When you're making parts, especially for aerospace, automotive, or even smartphones, precision is everything. But old-school plus or minus tolerances just don't cut it anymore. Back in the day, if you wanted a side to be perfectly flat, your only option was to tighten the size tolerance, which made everything more expensive. If you didn't, you could end up with parts like this. Not flat, not square, and definitely not what you intended. Or maybe the sides aren't even parallel or perpendicular, even though your design depends on it. So yeah, without better control, things can go wrong fast. That's why GD&T, or geometric dimensioning and tolerancing, was created, all the way back in the 1940s by the military. And over time, it became the universal way to communicate design intent. What matters, what doesn't, and how precise things really need to be. GD&T is a symbolic language that tells manufacturers not just how big something is, but how flat, straight, angled, or perfectly placed it needs to be. Now let's check out the symbol chart. There are a lot of symbols, but here are the big ones you should know. Position controls where a feature is located. Profile controls shape and contour. And runout makes sure rotating parts don't wobble. The rest? They fall into two main categories: form tolerances and orientation tolerances. These symbols help designers, machinists, and inspectors all stay on the same page. No guesswork, just clarity. Let's break down a key term. A datum is a reference point, edge, or feature you measure from. Think of it like an anchor. It's labeled with capital letters like A, B, or C, and tells us where to start measuring things like orientation or location. Now let's go over an example. For this box, we place datum A at the bottom. Then, the feature control frame tells us the left side is perpendicular to the bottom, where datum A is, within 5/1000ths of an inch. That 5 thou is the geometric tolerance, the box number. That's your exact target, or basic dimension. Then we define datum B at the left edge of the part. The next geometric tolerance says the right edge is parallel to datum B, within 3/1000ths of an inch. These datums and tolerances keep the part square, but with allowed variation. So next time you see symbols like these on a drawing, you'll know it's not just decoration. It's the key to making parts that actually work. Now here's a question for you. What's the difference between straightness and flatness? Are they the same? And how about circularity versus cylindricity? Drop your answer in the comments, and hit follow for more tips on blueprints, engineering, and machining.